Hi, I'm Kyra.
I'm Ale.
And we're going to explain what's on this optical table. So these are screws.
This is a Allen key set.
Okay, moving away from the screws, we have here a camera for photographing the table.
This is actually a camera for photographing biological samples.
This is also a camera.
This is a single photon detector, and these come together.
And that is a photon tool that catches photons, sees photons, hears, breathes, lives photons.
This catches photons.
This looks different than last time I saw it. This here is extremely important to the operations of the optical table. This is the sensor system, if I had to guess.
This is a magnet that we can control and can produce a field of up to 0.3 Tesla in any direction we want.
Moving along. This whole situation here, it's not really important. We'll move on.
This is the most important part of the microscope. This is where the samples are going to be. And there's a stage that we can control so that we can scan the samples, and also you can apply light in a very particular way that is called total internal reflection fluorescence microscopy. And on top of that, we'll position the magnet once I've done the calibration.
So these are the pieces of the quantum microscope. They are lenses. They are lenses.
This is an optical path with lenses and mirrors, like Kyra said, that can chop the laser light into tiny pulses.
This is a laser. Pause. This is intense laser radiation. This makes the lasers for the microscope. Yep, I'm confident about that one. Locking it in.
This is a laser system with 4 different wavelengths that we can control via TTL. And yeah, so this provides the illumination that we need to investigate our samples.
This is an oscilloscope. This helps with probing and gigahertz.
This is an oscilloscope. It's written right there. That's probably why Kyra said it. It's used to read voltages. Above
me is this extra big table to make things more dramatic or something, I'm not sure.
These are 2 controllers for the sample stage. One that controls coarse motion and one that controls fine motion, to actually look at different parts of the samples, focus in different planes, and so on. This is a sensor for magnetic field, and right now it's set up to do a calibration of this big magnet so that I'm able to control it via Python code.
Over here we have the stereo system for playing music when the people just want to bring the vibe stuff. It's really complicated, really complex stereo system. Yeah.
Over here we have some of the electronics. Basically all of this stuff is for powering up the magnet, which requires a shit ton of power. And this guy is a very fast TTL system that we can program and can produce basically nanosecond voltage pulses that can control the laser pulses via an acoustic optical modulator.